Hey guys, this is Coach Brian coming to you with your 7.3 notes. 7.3 is kind of reverse of what we've been doing in 1 and 2. In 1 and 2, we've been using equations to create graphs. Now we're going to reverse that process and we're going to use graphs and from them determine their equations. This is writing the equations of sinusoids or sinusoidal graphs. Another way to say this, or a way to say that, is just a sine wave. And to describe it, I'm just reading the definition right here. It's a smooth, periodic oscillation. So, smooth meaning it's curved, periodic means it's repeating itself, oscillation, it's a wave. It's represented by trips around the unit circle. So the process that we've been doing is we have been beginning by labeling our equation. So we have our K value, we have our A, we have our actual function, we have our B value, and we have our H value. So a lot of information kind of packed in there. First, just starting with K, this has been moved down 2. It is a sine function, and it has been reflected. Since that 3 right there is negative, that's a reflection. It has an amplitude of 3, because that's our A value. It's sine graph, so it starts in the center. Its horizontal shift is left by pi over 4. It has a period of 2 pi divided by b. Well, right now b is 4, so that's going to be pi over 2. And then the critical points are going to be the period divided by 4. So we would flip that and get pi over 8. So a lot of information right there. First thing, it's sine, so we're going to start in the center. Next, we've been moved down 2. So instead of our center line here being a 0, it's going to be a -2 because we've been moved down 2. We have an amplitude of 3, so that means to get, from the highs and the lows, we need to have a difference of 3. So -2 plus 3 gives me 1. And -2 take away 3 gives me -5. So there's my values right there for my y-axis. And the period goes pi over 2. Pi over 2 is my complete period. I am starting to the left, pi over 4. So normally, I'd start at 0, but I'm moving to the left. So it's going to bump everything to the left, which means I'm going to start at -pi over 4. Now, each little line is pi over 8. So if I go from -pi over 4 and I go up pi over 8, that's going to bring me to -pi over 8. If I do that again, that will bring me to 0. Then I'll get onto the positive side right here. 2 pi over 8 is the same thing as pi over 4. Then I've got 3 pi over 8. 4 pi over 8 is the same thing as pi over 2. And then I've got 5 pi over 8. And 6 pi over 8 is the same thing as 3 pi over 4. So that's where all my x values come from. Now, this graph has been reflected, so it's not only going to start in the center, it's going to start by going down, then middle, then up, then middle, then down, then middle, then up, then middle. So I've got all my critical points. I can go ahead and start to connect them with my sinusoidal wave, my smooth periodic oscillation. Once I get all these connected, I should have a nice sine wave. Now, the domain and the range of all sine and cosine waves is going to be all real numbers. I might have said domain and range just now. The domain of all sine and cosine waves is all real numbers. The range is going to be based on my y values. My lowest is -5. My highest is 1. So I have a range in brackets, because they are included, of -5 to 1. And that's a total vertical distance of 6, because the total distance between -5 and 1 is 6. So that's the process that we learned through 7.1 and 7.2. Now we're going to reverse that process. We're going to be given the graph, and we're going to need to find the equation. So we want to find the equation of the graph. Then we want to state the domain, range, and total vertical distance. We need to use degrees when it's degrees. How do we know that? Because there's a theta, and we use radians for problems with an x. It also indicates that we need to use the dots to indicate one cycle. Use the dots to indicate one cycle. So let's go ahead and start with the first one. It says use the sine graph in degrees. So that's nice that they told us this was a sine graph. Sometimes they don't let you know. If they don't tell you, what you would need to do is you would need to find the starting point, okay? And so far we've kind of, we've been given these vertical lines, but we're not always given those vertical lines. And so if you've got a ruler or, straight edge or something, you can add those lines in yourself. And dot to dot, just like the instructions said, dot to dot is one cycle. So this dot, or this initial dot, is in the center. And if they didn't tell you that this was a sine graph, that is how you would tell. Next, this graph begins by going up. That lets us know that it's not reflected. For vertical shifts, we need to look at our numbers on the y-axis. This graph, center line, midline, is at a height of 0, which means it has not been vertically shifted. Amplitude comes from the distance from the midline to the peak of a wave crest, or from the midline down to the trough. So if we look over, we can see that we go from 0 to 12. 0 to 12. That means we have an amplitude of 12. Horizontal shift. This graph, instead of starting at 0, 0, it's been moved to the left 120. Left 120. Period's going to be the distance or the amount of degrees in one cycle. So if you look at that, we have a dot at 360. We have a dot at -120. And so we want to take our final one, which is 360, and we want to subtract our initial one. When you subtract a negative, it just becomes addition. And so 360 plus 120 is 480. It means we have a period of 480. Now, the b value, a very important part of our equation, the b value is what determines the period. And if you remember, we find it by, we do period equals 360 over b. Well, this can be rearranged. B equals 360 over the period. And so what we can do here, since we know our period and we know it's in degrees, we can do that. It's 360 over 480. Now, you could simplify this, you could divide them both by 100, and that would knock off these zeros. And then you could actually divide them both by 12, GCF of 12. And that would give you 3 over 4. So our B value is 3 over 4. You can solve that algebraically for each one of these problems. Now that we have all our parts, we need to put them into the correct form. So last class we learned that the equation form is y equals k plus a times the trig function. And then we've got our parentheses, our b value, parentheses again, theta minus h. Excuse me. So that's our format. Another way you may see it is you may see the k value at the end. We'll just put plus or minus k. Either one of these is fine. Just pay attention to how it's asked on whatever you're doing. I know some of the electronic assignments had the k at the end. And if that's the case, just go ahead and answer it however it's formatted on your current assignment. Now, we need to put all of this information into this format. So we're going to write y equals, and we're going to put our k out front. Now, there was no vertical shift, so we don't actually need to do anything. And then our amplitude, it was not reflected, so we have a positive a value. This is a sine function. Our b, we said, was 3/4. And this problem is in degrees, so we're going to use theta. And then we moved left 120, and this is the one that has the sign that's backwards from what you would expect. So you would think left minus 120, but it's reversed, so we're going to do plus 120, and then we're going to close our parentheses. So that is the equation of this graph. Now, our domain, just like we said on question number 1, is all real numbers. Our range, this graph goes from -12 all the way up to +12, which gives us a total vertical distance of 24. Similarly, we can use the same process for cosine graphs. Now, it does say use cosine, and it tells us it's in radians. But if they didn't tell us that it was a cosine graph, we could just, again, go from dot to dot and realize that this graph does not start in the center, it starts high. And so if it starts high or low, it must be a cosine. Then, since it's a cosine graph that does start high, that means it is not reflected. Vertically, it does not start at 0. See how 0 is down there? It starts at, or has a midline, of 8. That means it's been shifted up 8. Additionally, it does not begin on the axis. It begins over at -25, which means it's been moved left or shifted left 25. The amplitude, well, the midline is 8, and the peaks of the crests are up at 18. That's a distance of 10. If we check the troughs, they're down at -2. That's also a distance of 10. So we have an amplitude of 10. This is in radians, and so to find the period of a wave in radians, we've been doing 2 pi over b. And if we count, just like we did on the last one, we take our initial measurement, or excuse me, our final measurement, 15, and we subtract our initial negative 25, that gives us 15 plus 25, which is 40. Our period is 40. And so 40 equals 2 pi over b. We can multiply both sides by b and divide by 40. And so we get b equals 2 pi over 40. And 2 and 40 can be reduced to pi over 20. So that's our b value. We have all the parts we need for our equation. Now we just need to write it out. It hasn't been reflected, but it has been vertically shifted. So we're going to write 8 plus 10 cosine. B value is pi over 20. This is radians, so we're going to say x. We move to the left, so we're going to say plus 25. Close our parentheses. There's our equation. We still have a domain of all real numbers. Our y values go from -2 up to 18, and that's a total vertical distance of 20. Lastly, it says use sine and degrees. Sine and degrees. This is a sine function. They do tell us that, but if you didn't know, you could look and see that the first dot is in the center. Starts in the center, that's a sine graph. It starts by traveling upwards, which lets me know it has not been reflected. Vertical, instead of starting at 0, it starts at 7, a y value of 7. So it's been moved up 7. Horizontally, our first point here is at -20. So it's been moved left 20. And then our last dot is over at 100. So if we take our final minus the initial, that turns into 100 plus 20, which is 120. That gives us a period of 120. Amplitude, our midline is at 7 and our highest peak of our crest is at 11. That's a difference of 4. And then we also go from 7 down to 3, so we have an amplitude of 4. And then just like question number 1, b equals the period, 360 divided by the period. So 360 divided by 120, you can knock off those zeros. 36 divided by 12 is 3. We have a b value of 3. Now we need to write this out, so we're going to write y equals, we have our vertical shift of 7. This is an unreflected sine graph with an amplitude of 4, so we're going to put 4 sine. We're going to open our parentheses. We need our b value, which is 3. Theta, we move to the left 20, so we're going to say plus 20. Close all of our parentheses, and we are done. The domain is going to be all real numbers. The range, the lowest point is at 3, highest point's at 11, and that's a vertical distance of 8. All right, hopefully this helps, and good luck with the rest of today's assignments.